Hello everyone, it is a pleasure to be here at Class 2021. Congratulations to the organizers for this great event, Educating for the Future. I'm going to comment on some tips on the techniques of using the slit lamp. We know that the biomicroscope is essential in every fitting of the contact lenses, and I have seen some cosmetic contact lenses sold without performing all the fitting steps, and I have seen that they do not do the corresponding controls with the biomicroscope before trying the lens and in the subsequent controls. It is very important that the examiner knows the models of the lamps that he will use in the examination. And some lamps come with lighting from either below and others from above, but we need to know all the indications on how their parts magnify the light and how they make the slit. That is, to know the lamp that we are going to use and have reassurance in its control. The previous important adjustments must be made, and this is being to calibrate the instrument with both left and right eyepieces and determine the interpupillary distance to achieve the 3D image that we want to observe. For this, a calibration rod is used. Another important thing is the correct position of the examiner, and we have to be comfortable. One hand goes on the focus lever and another hand goes on the lighting column. We will also use the hand that goes in the illumination column to invert the eyelid or move the eyelids and observe the ocular structures. And when we look at the right eye, we do it as shown in the image, and when we look at the left eye, we change the position of the hand. The position of the examinee is important because many times our chin and forehead support us well and we cannot focus correctly. Now, we already know the ABCs of slit lamp lighting techniques, and we can say that the diffuse light is the maximum width that the light beam has that we have observed. And when we use the filter with white light, we will use a diffuser along with it. And this diffuser helps us avoid dazzling the examinee during the process, and that excess tears are not produced as well. And many times we will need to help with this, but some lamps do not have the diffuser as you see it here. So we place a small nylon bag in front of the light to diffuse the light that we are projecting into the eye. We also have a parallel shaped slit, as you can see here, and we turn the knob sideways to form this parallel slit, which is approximately 1 to 3 millimeters in length. And if we keep narrowing the slit further, we make the optical section that measures almost less than 1 millimeter. We are going to evaluate all the structures, and we are going to register them. There are different records. In this case, I am showing you a record that is designed by IACLE, the International Association of Contact Lens Educators, which is very complete. Once we detect the anomalies, we will then compare them using the CCLRU graded scales, or we simply use the graded scales of Professor Nathan Ephron from Australia, and we then compare the photos from the anomalies, which we will then record it to see if it is a severe, medium, or a minimum condition. Over here, we have a registry that always makes sure that my mind is always knowing what ocular structures that I have to evaluate and that I have to keep in order. And I will start with the eyelids and then the eyelashes and record the findings of the right eye and also the left eye. Then I will look at the lacrimal points and also observe what goes on by using a diffuser light. And I will observe if they are free or if they are covered with the plug that ophthalmologists place to keep the tear stable. Now, we record then the findings, always both for the right and for the left eye. And in this case, we are looking at the meibomian glands, and for example, We record that the patient has a grade 2 dysfunction in the right eye, and we follow the meniscus tear, and we can also quantify it, and then the bulbar conjunctiva, and then after this we go on and explore the palpebral conjunctiva. And we must invert the eyelid in any contact lens adaptation, and we have to observe in what state the palpebral conjunctiva is, which is interacting with the lens and the cornea. And we can continue with the tear film and begin with the corneal evaluation using different lighting techniques. For example, we recorded a corneal vascularization that invaded the cornea by 2 millimeters, which I will then annotate and highlight it in a drawing. Then I will check the aqueous humor and observe the iris and record the iris what it has. For example, if it has hyperplasia at hour 4. I will see the eye as it is, as if it were a clock, and there I record the alteration that I found at the first hour, or at the second hour, or at the third or fourth hour, to be able to perfectly evaluate it. Now, observing the pupil is important, for example, to be able to identify different diameters between one or the other. Now, observing the lens and recording any changes, we will also see the vitreous humor and observe this while we also measure the angle between the iris and the cornea to see if it has a narrow anterior chamber that can lead to acute glaucoma. And so it is very important to know this. At this stage, we will draw out any anomaly that we see in the cornea or in the conjunctiva or in the eyelids, and so we do this so we mark it down. Using the lighting techniques, these being the diffused and the direct, we will observe in the first image the findings of a low magnification and that the filament of the slit lamp is on the right side. This means that the light falls from the right side. And in this second one, the second image, we observe the parallel shaped slit and observing a portion of the cornea. And we will keep narrowing the slit to find the optical section. And we have another type of direct lighting, that is the conical beam. And with this type of lighting, the anterior chamber is observed. Now, note that we are trying to shorten the height of the cleft until we reach a certain point, until the cornea and the lens are focused and the space between them is the anterior chamber. This is called direct lighting. Now, when we talk about indirect lighting, we will focus on one structure and then look at another. Now, in the retinal backlight for this case, I'm going to illuminate the retina and then set the illumination column to 0 degrees. Now with this, we then look at the filament in its position, which is the center. And when we use the light, it will bounce off of the retina and then return, which is why in this case, the pupil of the patient looks red colored. And then it is observed for what is in the way. And in this image, we see the lens with some opaque areas, and the iris backlighting can also be performed. Now that is, I illuminate the iris, and the light that bounces off the iris allows me to observe the corneal vascularization. Now, note that it appears that someone is lighting from behind so that they can see this vascularity. And the second image has a high magnification, and it is difficult to get to know the area of the cornea that is observed with the maximum magnification that is possible. And we always begin to observe the eye with minimum magnification and to observe in detail what we are magnifying, and in this case the image, and increasing the luminosity. And remember that the lamps have a rheostat that regulates the light intensity by itself. And the scleral dispersion is also an indirect illumination. That is to say that I have the light in one sector and then I look at another sector. And in this case, for example, we place the light in the limbar area on the left side, and it will come out on the opposite side through the right limbar area. And if we focus on the temporal side of things, the light comes out through the nasal side. And for this, the light makes a series of reflections through the entire cornea, and we can observe this in the central zone after some alteration or opacity that is very different from what can be seen with a parallel shaped slit. And for that reason, it is indirect light, and it illuminates one side and I observe another side. Specular reflection is another technique, and it is used to view the corneal endothelium. Another technique is that of filtered illumination, where we use a cobalt blue filter to observe any alteration, for example, the cornea. And we observe the image with the installation of fluorescein, and it is seen with a bluish coloration. To achieve contrast, we place a yellow filter in front of the observation system, and the green image remains. Another technique is the corneal profile, and it is very easy to perform, and it is very useful to observe the shape of the cornea and the anterior chamber. And we just use the optical section and the position in the observation column at 90 degrees. I will comment on some tips now in diffuse illumination with minimal magnification. The filament of the biomicroscope lamp can be seen on the right, or, in other words, we are illuminating the entire nasal vessel and we are observing the edge of the contact lens on the left side where the shadow is located. And it is for this reason we have to pass the lighting column from one side to the other. In the image on the right, in this case, the filament of the lamp is on the left side, and it is indicated by the red arrow as shown, and the shadow appears on the opposite side where the edge of the contact lens can be seen. And the filament of the light will tell me where the light comes from. Now you have to pay attention where the filament is and when looking at a photograph of an eye illuminated in diffuse light. With the parallel shaped slit that we have to know of, that we are observing a portion of the cornea in a three-dimensional way. The epithelium is observed on the anterior surface and the endothelium on the posterior surface. And it can be compared to a portion of melon, where the corneal epithelium would not be the melon rind, it would be the stoma, which would be the melon pulp, and where the seeds are found, the endothelium would be. With the parallel shaped slit, a cross section is made with the light, and the portion of the cornea is observed as a slice of melon. And we need to do a nasal temporal scan to be able to observe different portions of the cornea. And the parallel shaped slit is observed in a three-dimensional way.
Un comprobado líder en la práctica de lentes especiales y ojo seco. Cuando la precisión importa.
When we talk about the optical section, we are talking and looking at the cornea in a two-dimensional way. And so we observe the corneal epithelium on the front side and the corneal endothelium on the back side, and then the corneal stroma in the center. With the optical section, realistically, the light makes a cut in the cornea which reaches the lens. And this is how I am able to observe the slit in this position. And it is with the optical section the thicknesses are observed. and it resembles a pit in the melon where the thickness of the melon rind would be, as if we are observing the corneal epithelium, and the pulp is as if we were observing the thickness of the corneal stroma. And finally, the optical section is observed in a two-dimensional way. In this image, the optical section is observed, and the illumination column is located at 20 degrees. Observe in the image that the filament of the lamp is at 20 degrees. And so, in this way, the light is focused on the cornea and on the lens. And notice that the cornea is not very focused, and so we are focusing on the lens. We are also observing the thickness of the lens, the anterior face of the lens, the posterior face of the lens, and the anterior chamber can be seen. And so in this image, we can see the posterior chamber because the pupil is dilated. We can also observe all the layers of the cornea: the epithelium, Bowman's membrane, the stroma, the dual layer, and this layer is not observed because it is very thin, the cement membrane and the corneal endothelium. To see all these structures, we are going to use different lighting techniques. Observe, with the maximum width of light, with a cobalt blue filter and the one with the yellow filter, I can see this corneal erosion or corneal staining that is here as a rayon. And we observe that it is apparently very superficial, as we do not know, as an optical section is made, and we determine in which layer of the cornea the erosion is found. And so this image looks good green because the yellow filter is being used. And here we see a narrower parallel shaped slit, and we can see with the direct light where the corneal erosion actually is. And so the light shines from the left. Now also note that the filament of the lamp is at approximately 40 degrees. And if I keep looking at the corneal epithelium with a parallel shaped slit, where the light comes from the left side, we encounter the corneal infiltrates. The typical question that we wonder is in which layer of the cornea the infiltrates are found. To find out, we have to magnify the image and increase the light intensity with the rheostat. Using the optical section, we observe the anterior face of the cornea and the corneal stroma and the infiltrates. But, as we ask, where are these infiltrates? They are observed on the anterior surface, only in the corneal epithelium. With the optical section, we can perfectly locate in which layer of the cornea this alteration is actually found. With the parallel shaped slit, we see the corneal stroma, and in this image, the light is coming from the left. And if we look at the filament of the slit lamp, with direct and parallel shaped lighting, we can see the scar in the yellow circle. Indirectly, we are also observing a corneal vascularization in the sector of the green circle, and the light bounced off the iris and the light returned so that we can see the vascularization in more detail. And this technique is called iris backlighting. In this image, in the parallel shaped slit, we see the corneal stroma and the illumination, but not focused iris. We observe the anterior and posterior face of the cornea, and we see the scars from the refractive surgery and radial keratotomy. In surgery, the entire epithelium and the Bowman's membrane were crossed. The membrane does not regenerate, and so that is why it leaves a scar. In this image that we are observing, a cobalt blue filter with fluorescein is used, with a low to medium magnification, and it is observed in blue, because the yellow filter has not been placed yet. And so we need to see if it really is a scar. We actually saw sunken areas where the fluorescein is lodged. And if the epithelium is really altered, we can see it with a white light and the optical section. In this image is the blue cobalt filter with the yellow filter, because we are looking at green instead of blue. And so then we get to observe, in this case very clearly, the tear meniscus and the corneal stroma, where the intrastromal rings are found. And we can observe then also an epithelial erosion. To be able to observe the depth of the ring and the depth of the erosion, we use a blue light with fluorescein in the optical section. Then pass it to a white light, where we increase the illumination and we magnify, and thus we can see what is the depth where the ring and the erosion are. If we look at the image on the left, with fluorescein cobalt blue filter with no yellow filter with high magnification, we observe a corneal erosion where the black circle is found. This erosion, as seen in the image on the right, with a parallel-shaped white slit, the same erosion is observed in the corneal epithelium, because it is observed only in the anterior chamber of the parallel-shaped slit. The picture on the right does not have the blue light like the picture on the left, so as to see both pictures in more detail. And so, again, blue light, magnification, optical section, and then we can see this corneal erosion. We are also able to observe the Descemet's membrane with a parallel-shaped slit, with a direct light, and what we do is give it a high magnification and a high illumination to be able to have this image. And here we observe, if you remember how the melon portion looked like, the corneal epithelium is on the front side, and on the back side we see the striae in the Descemet's membrane and then the stroma. Now the last layer of the cornea, the endothelium, is observed with high magnification and high illumination. The illumination technique to see the corneal endothelium is specular reflection, and we are going to do it with a parallel-shaped slit. And the characteristic to achieve this technique is that the angle of the incidence must be equal to the angle of the reflection. And if I have to move the observation system at an angle equal to that of the light, and in this way I can observe a greater surface of the corneal endothelium. Another characteristic of the technique is that it is observed by only one eyepiece. This is what we have to observe, the corneal endothelium. And remember that the corneal endothelium is a single layer of cells that does not regenerate. It always has to be in perfect condition, and we have to avoid hypoxia when fitting contact lenses so as not to alter the endothelium. We can easily observe the specular refraction in the technique, and in the parallel-shaped slit we see the epithelium in the anterior face. Where the yellow circle is, the endothelium is observed, and the green circle shows that it is observed only by one eyepiece. Specular reflection lighting technique can be performed easily. Why? If you see in this image, where we have seen the corneal erosion, it does not have much magnification, it does not have much illumination, and we see the corneal alteration. But now, do not observe the corneal alteration, observe the filament of the lamp reflected in the cornea. We magnify the image and increase the lighting. In the second image, we observe that the filament of the lamp is located on the anterior face of the parallel-shaped slit, and in the corneal epithelium and the endothelial cells are observed on the posterior face of the parallel-shaped slit. In this second image, this endothelium is not yet in focus, and I continue to magnify and increase the light. The filament of the lamp continues on the anterior face of the parallel-shaped slit. I observe the corneal endothelium in the right area of the parallel-shaped slit. The filament of the lamp is located on the anterior face of the parallel-shaped slit in the corneal epithelium, and this location serves as a guide to achieve the technique and find the endothelium. In the image on the right, it is at maximum magnification and maximum illumination, and the environment is dark. And in this technique, I place the observation system a few degrees to the opposite side from where the illumination column is, and it is possible to observe more of the endothelium surface. And so the endothelium is observed as if it were a lunar surface. And so the yellow mark, which shows the corneal endothelium, only that area of the endothelium is observed. And to observe the different areas of the endothelium, a scan must be carried out with the focusing system and the illumination column. In summary, to perform the specular reflection and observe the endothelium, they start from an image with low illumination and low magnification, and then magnify the image and increase the illumination and place the filament lamp on the anterior face of the parallel-shaped slit, and that is in the corneal epithelium, and on the posterior face of the parallel-shaped slit we can see the corneal endothelium. We can also use the specular reflection technique in order to observe a tear. Observe the filament of the lamp on the anterior face of the parallel-shaped slit, focusing on the anterior area, and thus we observe an interference pattern of the tear, and we can evaluate it. For example, if that interference pattern is very colored, it is a very fatty tear, and we can record the quality of the tear. It was only carried out with the image of the specular reflection observing the anterior face of the parallel-shaped slit. And in the image, the tear layer that we are evaluating is well focused, and we observe the endothelium area not very focused. And so, in summary, in this presentation, we have seen that the structure of the cornea can be observed with the ABC of illumination techniques with filtered illumination and specular reflection, and it takes a process of learning, practice, and dedication that we must always identify the anomalies of the anterior segment and the ocular annexes before placing the contact lens and in the posterior controls. I really appreciate the attention. Thank you very much, class, for the great event.